This call is now being recorded.
Okay, so good afternoon all. So today we will start with the next chapter. The name of the chapter is chapter number 5, shear force and the bending moment diagram. In short, we can call it as a Sfd and the Bmd. Okay, so this particular chapter is mostly applicable for the one of the civil structure which is called as a beam. You know the basic structure of that particular beam, where it is used in the civil structures. Okay, so in that particular beam, that beam is subjected to the number of loadings, and due to that particular loadings, that particular beam, it is subjected to the shear forces and the bending moment. So in particular chapter, our requirement is that if the beam is subjected to the number of loadings, so number of forces, whatever the forces are on particular beam, by particular forces, we are calculating shear force induced particular beam at each and every point. Similarly, due to the same force, that beam is subjected to bending moment.
Sir, voice is breaking.
We are going to calculate the bending.
Sir, voice is breaking.
सर आवाज आहे ना.
Not be audible, please check.
No, sir, breaking.
No sir. Once again.
Wait, am I audible now? Please check.
Yes, sir.
Yes sir.
Okay.
Yes, sir.
Yes,
Okay.
sir.
So we are discussing about the shear force and the bending moment diagram. So why this particular chapter we have to study in the mechanics of material, that we are going to discuss first. Okay, so we know that the beam is one of the horizontal structure. Always the beam is one of the horizontal structure. That beam is subjected to the number of forces. Maybe that beam is subjected to the point load, beam is subjected to the UDL, beam is subjected to the UVL, the beam is subjected to the couple. If number of loads are applied on that particular beam, due to that particular number of forces, that beam is subjected to the shear force and bending moment. So what is our requirement? Due to that particular number of forces are applied on that particular beam, what we are doing? We are going to calculate the shear force at each and every point. Maybe we are calculating the shear force at the two supports. We are calculating the force at the center point wherever the loads are applied. We are calculating the shear force at each and every point, and in addition to that, we are calculating the bending moment also. That means initially we are going for the analytical calculation, and whatever the value we have calculated for the shear force, whatever value we have calculated for the bending moment, that shear force and bending moment calculation will be converted into one diagram, and that particular diagram is called as a shear force diagram. Means it is called as a SFD. And another diagram which is drawn by using the bending moment calculation, that diagram is called as a bending moment diagram, or in short we can call it as a BMD. So now here, which point we are going to discuss in this particular chapter? So this is the syllabus content. So you can see here, this is the syllabus content. What it indicates? First of all, we have to discuss about the basic concepts of the shear force and the bending moment. What is the definition of the shear force? What is the definition of bending moment? That basic concepts we are going to discuss first. After that, we are going to discuss the different types of the beams. After that, we are going to discuss the different types of the beams in which we have to go for the SFD and the BMD. Then after that, we are going to discuss about the different types of supports. You know that the different types of the supports are there. Maybe roller support is there, hinged support is there, fixed support is there. That each and every type of support we are going to discuss in this particular chapter. After that, we are going to discuss about the different types of the loads. Maybe we are going to discuss about the concentrated load, which is also called as a point load. Then we'll discuss about the UDL, then UVL, then couple. So these different types of the loads also we are going to discuss in this particular chapter. After that, if I have to go for SFD and BMD for the simply supported beam, if I have to go for the SFD and BMD for the cantilever beam, if I have to go for the SFD and BMD for the overhanging beam, which sign conventions I have to use? Because in each and every type of beam, we have to go for the calculation of shear force and the bending moment. So if I have to do the calculation of shear force and the bending moment, at that time, I have to use some of the sign convention. From which side of the beam, either from the left side or either from the right side of the beam, I have to start that particular calculation. So that sign conventions also we are going to discuss in this particular chapter. And by using that particular sign conventions, we have to go for the calculation of shear force, we have to go for the calculation of bending moment, and then whatever the calculation we have made, that calculation we can convert in one of the diagram. That diagrams are called as the SFD and another is the BMD. In addition to that, in this particular chapter, we are going to discuss about the two theoretical points, that is point of contra shear and the point of contraflexure. So what that particular 2 points indicates? This 2 point indicates about where shear force is zero, where bending moment maximum. Similarly, where bending moment zero and where bending moment maximum. So this, whatever the statement I have discussed just now, where the shear force is zero, where shear force is maximum. Similarly, where bending moment is zero and where bending moment is maximum. So these two concepts we are going to discuss in this particular point of contra shear and the point of contraflexure. Why we have to discuss this particular 2 points also? Because in many types of the numericals, you will get this particular points during the calculation. In some of the types of beams, you will get the point of contra shear. In some of the beams, you will get the point of contraflexure. If such types of the points are visible in that particular SFD and BMD, we have to indicate that particular points. We have to indicate particular points in that particular SFD and the BMD. Therefore, this point of contra shear and the point of contraflexure also we have to discuss in this particular chapter. Before starting the actual SFD and BMD for the supported beam, cantilever beam, and the overhanging beam. So in this particular chapter only, we have to draw the SFD and BMD for 3 types of beams. Out of that, the first one is a simply supported, second one is a overhanging beam, and the third one is a cantilever beam. But for the calculation of SFD and BMD, initially we will discuss about some of the theoretical parts, in the sense the different types of the beams, different types of the supports, and the different types of the loads. After this discuss about the sign conventions. Once the sign conventions are understood properly, then we'll go the actual calculation of SF and the BM. Okay, so maybe in between some voice is breaking, I will try to clear it. Maybe some range problem is there. If major problem you are facing, then try to inform me immediately. So due to the range problem, that things are happening. Just wait. Okay. So now we'll start with the first point, that is introduction. So in order to go for the introduction of this particular Sfd and Bmd, here I have considered two sample beams. That is the first beam. This is the simply supported beam, and the second beam, this is called as a cantilever beam. So the simply supported, afterwards we will go for the definition of the simply supported and the cantilever beam. But initially we'll discuss about the importance of the Sfd and the Bmd. As we know that this particular beam is one of the structural member, or beam is one of the horizontal structure which is subjected to the number of loads applied. The beam is one of the horizontal structure, or it is one of the structural member which is subjected to the number of loads, and whatever the load is applied on that particular beam, that load is always perpendicular to the horizontal axis. Because this is the beam, let us assume that this is the beam and this is the axis of that particular beam. Okay, so whatever the load is applied, for example, if the point load is applied, this point load is perpendicular to this particular axis. Similarly, if this beam is subjected to the UDL, that UDL we have to convert into the point load. Means again, whatever the point load we have converted, again it is perpendicular to the axis. If that beam is subjected to the UVL, again we have to convert that particular UVL into the point load. Okay, again that particular UVL which is converted into the point load, it is again perpendicular to that particular axis. That means whatever the number of loads are applied on that particular beam which are perpendicular to that particular axis, due to the number of loads applied on that particular beam, the bending of the beam is taking place. For example, let's take an example. This is the figure number 1. In that, this is the figure number 1. In that, this particular, whatever the curve I have drawn at the bottom side, in the figure number 1, I have drawn that particular curve. What it indicates, due to the number of forces are applied on that particular beam, the bending is taking place in the downward direction. Because whatever the forces are applied, that forces are also applied in the downward direction. Therefore, the bending is also taking place in the downward direction. So, due to that particular bending, or due to that particular number of forces applied on this particular beam, maybe here one point load is there, and then here UDL is there. Similarly, in the second figure, also you can see the cantilever beam is there, and that particular cantilever beam, it is subjected to the one point load, that is 8 kilonewton point load, and another point load is applied at the frame. That means this cantilever beam is subjected to the two loads which are applied in the downward direction. So due to that particular load, the bending is taking place in the downward direction. Means if the beam is subjected to the number of forces which are perpendicular to the axis of that particular beam, the bending is also taking place. In addition to that, the shear force is also developed in that particular beam. Maybe the shear force is developed at this particular point A. In the figure number 1, shear force is developed at point A. Similarly, some shear force will be developed at point B. Similarly, some shear force is developed at point C. Similarly, in case of a second figure, some amount of shear force is developed at this particular point C, means at the fixed support. Some shear force is developed at this particular point B. Some amount of shear force is developed at this particular point A. And that shear forces we have to calculate in this particular chapter. At the same time, whatever the bending moment is developed at point A, B, C, similarly in the second figure at point A, B and C, that bending moment also we have to calculate. And whatever the bending is taking place in the downward direction, in case of any type of beam, in case of any type of the beam, due to the number of forces, whatever the bending is taking place, that bending is depends upon the 4 parameters. That bending is depends upon the 4 parameters. In that, the first parameter is the amount and the type of load. Whatever the bending is taking place in the downward direction, that bending is depends upon the 4 parameters. In that, the first one is the amount and the type of load. Amount means how much amount of load is applied on that particular beam, whether 10 kilonewton load is there, 20 is there, 30 is there, 40 is there, that amount of load. And type of load, whatever the load is applied, whether that applied load is the point load, whether it is UDL, whether it is UVL. That means amount of load and the type of load. Based on this particular also, how much amount of bending is taking place. Then second is the length of beam. Whatever the bending is taking place in the downward direction, that bending is also depends upon the second parameter, which is called as a length of the beam. If the length of beam is too high or the length of beam is too maximum, the maximum bending will be taking place. If the length of beam is very less, the minimum bending will be taking place. This is the second parameter. Then third is type of beam. Which type of beam is there? Whether simply supported beam is there, whether cantilever beam is there, or whether overhanging beam is there. Based on this particular type of beam also, that bending will be depends. And the last important parameter is the elasticity. You know the property elasticity. Elasticity means when the force is applied on the body, the deformation is taking place. If the force will be removed, that body regain to its original position. So that concept is called as a elasticity. Means if the beam is subjected to the number of forces, due to that particular number of forces, the bending moment of the beam is taking place in the downward direction. Why it is taking place? Because whatever the material of that particular beam is there, that material is having the some amount of elasticity property. If the material is totally rigid, material is not elastic, the bending will not be taking place. If the material is not elastic, the bending will not be taking place. If the material is elastic, and if I will apply the force on that particular elastic material, then and then only deformation will be taking place. For the non-elastic materials, the deformation will not be taking place. Therefore, please keep in mind, due to the number of forces, whatever the bending of the beam is taking place in the downward direction, that bending of the beam is depends upon the four parameters. In that, first one is a amount of load and the type of load. Amount of load and the type of load. Second, length of the beam, whether your length of the beam is maximum or whether length of the beam is minimum. Based on this also, your bending is depends. Third one is a type of beam. Which type of beam we have used for the analysis, whether it is simply supported, whether it is overhanging, or whether it is cantilever. Based on the types of beams also, your bending is depends. And last important parameter is the elasticity. Whatever the material is used for that particular beam, maybe that cement is there, maybe concrete is there, the deformation, bending of the beam is not visible in actual condition. Please keep in mind. If you assume the beam structure at your home, that particular beam is subjected to the number of loads from the top side, but that bending is not visible at your actual eye, but some amount of bending is taking place. Why that bending is taking place? Because whatever the material is used for that particular beam, that material is having some elasticity property. If that material is non-elastic, bending will not be taking place, or the deformation will not be taking place. But that particular beam is also one of the elastic material. Therefore, that elasticity of that particular beam, it also plays very important role in that particular beam. Now, while designing the such types of the structure, now if I have to go for the designing of any building, if I have to start the construction, so before the construction, it is not possible to start the actual civil work, or it is not possible to start your actual construction. Before that, we have to go for the calculation. Therefore, before starting the civil structure, it is necessary, it is compulsory to go for the shear force calculation and the bending moment calculation to the each and every point. Before starting the structure or before designing these particular structures, it is necessary or it is compulsory to find out the shear force at each and every point of the beam, as well as bending moment at each and every point of the beam. That means we are doing the theoretical calculation. We are calculating the shear force at point A, B, C, D, E, F based on the number of points available in that particular beam. Similarly, we are calculating the bending moment at point A, B, C, D, E, like that, number of points present in that particular beam. And after the calculation, by using that shear force and by using that particular bending moment, we are going to draw one diagram. That diagram is called as a shear force diagram and the bending moment diagram. That means whatever the theoretical calculation we have made, that theoretical calculation will convert in graphical form, and that diagrams and whatever the graphical form you will get in the form of diagrams, that diagrams are called as a shear force diagram and the bending moment diagram. And by observing the nature of that particular SFD and BMD, we can easily say that where shear force is zero, where shear force is maximum. Similarly, where bending moment is zero and where bending moment is maximum. By the theoretical calculation only, it is not possible, or it is not possible to indicate where the critical points are present in that particular beam. Critical point in the sense where shear force zero, where shear force maximum. Similarly, where bending moment zero, where bending moment is maximum. Therefore, in order to avoid such types of the difficulties, what I am doing, that theoretical calculation I will represent in the form of diagrams. That diagrams are called as a SFD and another diagram is called as a BMD. Therefore, in order to go for the detailed analysis of the beam structure in the civil applications, or maybe some type of the structures are also available in the mechanical also. So before designing such types of the structure, initially we have to go for the theoretical calculation. By using that particular theoretical calculation, we have to go for the deep study in the form of diagrams, and from that diagram, from that particular graph, or from that particular SFD and BMD, you will get the detailed idea about the critical points present in that particular beam. If the critical points are present in that particular beam, then again we have to go for the redesigning of that particular beam. Once you will get the feasible results, then by using that particular calculation, we can go for the actual construction. Therefore, this concept of SFD and BMD, it also plays very important role in case of a civil structure or in case of a mechanical structure. So simply, which process we are following, whatever the type of beam is given to you, and along with that particular type of beam, whatever the number of loads are applied on that particular beam, by using that number of forces, initially we have to go for the theoretical calculation. That means we are calculating the shear force at each and every point. We are calculating bending moment at each and every point, and afterwards, by using that shear force and by using that particular bending moment, we'll draw the two diagrams which are called as a SFD and the BMD. Okay, so this is about the basic introductions related to the SFD and the BMD. Now, for further analysis, first of all, we'll discuss about the different types of the beams. In our syllabus, we have to go for the analysis of simply supported, cantilever and the overhanging only. But here we have to understand the different types of the beams also. So first of all, we'll start with the different types of the beams. Now the first type, whatever here it is represented, that is the first beam is called as a cantilever beam. So what is the basic definition of the cantilever beam? From that particular construction itself, we can easily say that what is the basic definition of the cantilever beam. Okay, the beam whose one end is fixed and another end is free, that beam is called as a cantilever beam. The first diagram represents the cantilever beam, in which the beam whose one end is fixed means whatever the left side of the beam is there, that left side is fixed, and whatever the right side of the beam is there, that right side of the beam is totally free. If the structure is given like that, then this particular beam is called as a cantilever beam. So once again, I will repeat the definition. The beam whose one end is fixed and another end is free, that beam is called as a cantilever beam. Then second, here it is given, simply supported beam. But what is the definition of simply supported beam? The beam which is just rest on its supports. The beam which is just rest on its support, or it is supported at the both ends only. What is the definition of simply supported beam? The beam which is just rest on two supports, or the beam which is supported at both ends only. The beam which is supported at the both ends only. Now in this particular second figure, you can see one horizontal structure beam is there and it is supported at the two ends. So this is the one support at the left side and this is the another support at the right side. That means whatever the two ends of the beam is there, at these two ends only the beam is supported. Therefore this particular particular beam is called as a simply supported beam. Please keep in mind the beam which is just rest on two supports, or it is supported at both ends only. जिथं बीम तुमचा संपतोय म्हणजे लेफ्ट साइडला कुठं बीम संपलाय बघा, at this particular point your beam is finished. Similarly at the right side, at this particular point your beam is finished. At that point only, if that beam is supported, then this particular beam is called as a simply supported beam. म्हणजे दोन्ही लेफ्ट साइडला आणि राईट साइडला जिथं बीम संपतोय त्या ठिकाणी जर आपण दोन सपोर्ट दिले असतील तर अशा बीमला आपण काय म्हणतो, सिम्पली बीम म्हणतो. कॅन्टिलिव्हर मध्ये एकाच बाजूला सपोर्ट आहे, दुसऱ्या बाजूला बीम टोटली फ्री आहे. सिम्पली सपोर्टेड मध्ये इट इज सपोर्टेड ऍट द टू एंड्स ओनली. जिथं तुमचा एंड आहे बीमचा त्या ठिकाणी जर सपोर्ट असतील, एक लेफ्ट साइडला आणि एक राईट साइडला, तर त्या बीमला आपण काय म्हणतो, सिम्पली सपोर्टेड बीम म्हणतो. देन थर्ड, overhanging beam. Name itself suggests that. Overhanging beam. What is meant by the overhanging beam? The beam whose end portions are extended beyond the support. The beam whose end portions are extended beyond the support, either from one side or either from the both side. That particular beam is called as a overhanging beam. Name itself suggests that. Overhanging means, baga, in this particular overhanging beam, in the figure number 3 or in the C figure, the supports are present not at the free end. जिथं बीम तुमचा संपतोय त्या ठिकाणी सपोर्ट नाहीयेत, म्हणजे सपोर्टच्या बाहेरच्या बाजूला पण बीम काय झालेला आहे, एक्सटेंड झालेला आहे. तसंच राईट साइडला सपोर्टच्या बाहेरच्या बाजूला पण बीम काय झालेला आहे, एक्सटेंड झालेला आहे. मीन्स द बीम whose end portions are extended beyond the support, म्हणजे तुमच्या बीमचे एंड पोर्शनच्या जर बाजूला गेले असतील, मग ते एका साइडला असू द्या किंवा दोन्ही साइडला असतात, तर such types of beams are called as. Observe the figure in which the support is present
Sir,
at
voice
this particular
breaking.
point. Now it is audible.
Yes, sir.
Okay, so we are discussing about the third figure, in which is called as overhanging. What is the definition? The beam whose end portions are extended beyond the support. If you observe the figure number 3, in which at the left side also the portion of the beam is extended beyond the support, at the right side also the portion of the beam is extended beyond the support. पण जिथं बीम तुमचा संपतोय तिथंच सपोर्ट नाहीये, तर सपोर्टच्या बाहेरच्या बाजूला पण तुमचा बीम काय झालेला आहे, एक्सटेंड झालेला आहे. Therefore types of the beams are called as a overhanging beam. So I will give the definition. The beam whose end portions are extended beyond the support at one side or from the both sides, that particular beam is called as a overhanging beam. If you compare the simply supported beam and the overhanging beam to each other, if you compare the simply supported beam or the overhanging beam to each other, in simply supported also the two supports are there, in overhanging also two supports are there, but in simply supported beam the supports are given at the end portions only. In simply supported, the supports are given at the end portion only, but in case of a overhanging beam, the supports are not at the end portion. That end portions are extended beyond the support. म्हणजे सपोर्टच्या बाहेरच्या बाजूला पण तुमचा बीम काय झालेला आहे, एक्सटेंड झालेला आहे. Therefore, this particular beam is called as a overhanging beam. Okay, now the fourth or the beam number 4 or D, it is called as a continuous beam. What is meant by the continuous beam? What is meant by the continuous beam? Yes, can anybody? By observing this particular figure, what is meant by the continuous beam? Yes, simple. The beam which is rest on more than two supports. The beam which is rest on more than two supports, that particular beam is called as a continuous beam. The beam which is rest on, or the beam which is supported by number of supports. Number of support mean the sense, if it is supported more than two supports, then that particular beam is called as a continuous beam. Because in the figure number 2 and in the figure number 3, means in case of a simply supported beam and in case of a overhanging beam, only two supports are there. In case of a simply supported and in case of a overhanging, only two supports are there. But in the figure number 4, the beam is supported by more than two supports. That means the two supports are present. One support is present at the left side, one support is present at the right side, and at the center portion also. Again, the two supports are there. You can see in the figure. So such types of the beam is called as a continuous beam. Therefore, simple definition is there for the continuous beam: the beam which is rest on more than two support, which is called as a continuous beam. So the cantilever means one end is fixed, one end is free. Simply supported means the beam is supported at the two ends only. That beam is called as a simply supported. Third, overhanging, the beam whose end portions are extended beyond the support, either from one side or either from the both sides. That particular beam is called as a overhanging. And the last, fourth, continuous, the beam is supported by the number of supports, or if it is rest on more than two supports, एकापेक्षा दोन पेक्षा जर जास्त सपोर्ट एका बीमला जर दिलेले असतील तर त्या बीमला आपण काय म्हणतो, कंटिन्युअस बीम म्हणतो. सो दीज आर द बेसिक 4 टाइप्स which we have to study in this particular chapter. Fifth, fixed ended beam. Name itself suggests that fixed ended means the beam which is fixed from the both sides. Fixed ended means the beam which is fixed from the both sides. That beam is called as a fixed ended beam. Therefore, you can see at the left side also the beam is totally fixed. At the right side also the beam is totally fixed. Therefore, the figure number 5, it is called as a fixed ended beam, in which both the supports which are present at the left side and the right sides are fixed. That beam is called as a fixed ended beam. And the last, the 6th type of the beam is called as a cantilever simply supported beam. Cantilever means one end is fixed, you can see at the left side, and another end roller support is given. That means the figure number 6 is the combination of the cantilever beam and the simply supported beam. Why it is the combination of the cantilever and the simply support? Because cantilever, one end is fixed, which is given at the left side. You can see in the figure, the left side is totally fixed. Therefore, fixed support is there. But at the right side, the roller support is there. Therefore, that roller support is given at the free end, and this particular beam, last figure, is the combination of the cantilever beam and the simply supported beam. Therefore, this particular beam is called as a cantilever simply supported beam. So these are the basic 6 types of the beams, but out of that, in this particular chapter, we have to study only first 3 beams, or we have to solve the numericals based on the first, that is cantilever beam, second simply supported beam, and third one is a overhanging beam. Remaining 3 figures are just for your understanding in order to get the proper difference between all the types of beams. Therefore, please give the maximum focus on the first beam, cantilever. One end is fixed, another end is free, is called as a cantilever. Second, simply supported, the beam is supported at the 2 ends only. That beam is called as a simply supported. And third one, overhanging, means the beam whose end portions are extended beyond the support. सपोर्टच्या बाहेरच्या बाजूला पण तुमचा बीम एक्सटेंड झालेला असेल, मग तो एका बाजूला असू द्या किंवा दुसऱ्या बाजूला पण असू द्या. किंवा दोन्ही बाजूला असू द्या, that particular beam is called as a overhanging beam. So these are the basic types of the beam. Now we'll discuss about the types of loads. It is very simple. Types of the loads. Basically, there are three types of loads which are acting on that particular beam, and we have to study in this particular chapter. The first one is a point load. You can see the first figure. This is the 1, this is 2, this is 3, this is 4, and this is 5. The first point is called as a point load. What is the definition of point load? The point load is also called as a concentrated load. The point load is also called as a concentrated load. So what is the definition of the point load? Simple. The load which acts at a point on beam is called as a point load. For example, this is the beam which is supported at the two ends. You can see this is point A and this is point B, and at the center point one point is there which is called as a point C, and at this particular point C, if one load is applied, so this particular load is called as a point load. For example, its magnitude is 5 kilonewton. So this particular figure, whatever I have drawn, whatever the load is applied on that particular beam, that load is called as a point load. Means the load which acts at a point on beam. Where this particular point 5 kilonewton load is applied, it is applied at this particular point C. The load which is acts at a point on the beam, that particular load is called as a point load. एखाद्या पॉइंटला जर एक वर्टिकल डायरेक्शन मध्ये जर एक लोड अप्लाय झालेला असेल, त्याचा तो काय म्हणतात पॉइंट लोड. मग कुठल्या पण पॉइंटला आहे, मे बी इट विल बी ऍक्टिंग ऍट द it will be at some left side, sometimes it will be at some another side, but at any point at a single only, if the load is applied, that load is called as a point load. Then second, uniformly distributed load, which is called as a, in short, it is called as UDL. So one more figure I will draw. UDL. It will be indicated like this. UDL. For example, its magnitude is 5 kilonewton per meter. This is point A and this is B. If I have to indicate that particular UDL, it will be indicated like this. But what is the definition of UDL? What is the definition of the UDL? The load which is uniformly distributed. The load which is uniform, very important, please keep in mind. The load which is uniformly distributed or spread over the beam.
Sir, voice is breaking, sir.
Sir, voice is breaking.
Yes, sir. Voice is breaking.
Okay, just hold for the one minute. I will clear this. Am I audible now? Please check. Okay. So we are discussing about the UDL. In short, it is in a long form. The long form of the UDL is the uniformly distributed load. Okay. So what is the definition of UDL? The load which is uniformly distributed or spread over the beam is known as UDL. In that definition, the word is important as a uniformly distributed. So, what is the figure I have drawn here? What is the figure I have drawn here? The one beam is there. On that particular beam, the UDL I have drawn, and its magnitude is 5 kilonewton. So, as per the definition, the load which is uniformly distributed over the length. What is the length of this particular beam? The length of beam will be considered as a 5 meter. So, on this particular 5 meter length, if the load is uniformly distributed, that means whatever the magnitude of the load is there at point A, same magnitude will be there at the center point. Same magnitude will be there at this particular point B. So whatever the magnitude is present at point A, at point B, at point C, that means it is uniformly distributed over the length. It is uniformly spread over the length of that particular beam. That particular load is called as a UDL. In case of a point load, the point load is applied at the single point only. The point load is applied at the single point only, but the UDL is spread over the length. The UDL is spread over the length. Therefore, that particular load is called as a uniformly distributed load. In short, it is called as a UDL. But if such types of the UDL is given in the beam, we have to convert that particular UDL into the point load. This is very important. Whatever the magnitude of the UDL is given and whatever the length of that particular beam is given, that UDL we have to convert into the point load. Therefore, the point load is equal to W into L. What is that particular W? W means whatever the magnitude is given. How much? 5 kilonewton meter. What is the length of the beam? 5 meter. So it will get 5 kilonewton. That means by using that particular magnitude of UDL and by using the length of that particular beam, I have converted that particular UDL into the point load. And if the UDL is given in the figure, how to convert that particular UDL? We are having the formula, that is point load is equal to W into L. That W means 5 kilonewton per meter, which is given on that particular beam. Length of the beam is given 5 meter. So 5 into 5, 25. This meter from the numerator, meter from the denominator, it will get cancelled. Only you will get the 25 kilonewton as a converted point load from the UDL, which is applied on that particular beam. Therefore, please keep in mind, if the point load is given in the figure, you can take this particular point load as it is for the further calculation. If UDL is given, it is not possible to take that particular UDL value as it is for the further calculation. Please keep in mind, UDL is 10 kilonewton per meter. It is not possible to take that particular 10 kilonewton per meter for the further calculation. What is our requirement? We have to convert that UDL into the point load. And to convert that particular UDL into the point load, we are having the formula W into L. W means magnitude of the UDL, which is given in kilonewton per meter, and the length. On how much amount of length UDL is applied, that length we have to consider. Now in this particular figure, the UDL is spread over the beam. जेवढी काय त्या बीमची लेंथ आहे त्या सगळ्या बीमवर तुमचा UDL काय झालेला आहे, स्प्रेड झालेला आहे. त्यामुळे मी काय केलं, सगळी लेंथ पॉइंट लोड कन्वर्ट करण्याला कन्सिडर केले. फॉर एक्झाम्पल, सम ऑफ द ऍप्लिकेशन, द लेंथ ऑफ द बीम इज 10 meter. Okay, and out of that particular 10 meter, on 5 meter only the UDL is applied. Out of the 10 meter length, on 5 meter only the UDL is applied. So while converting that particular 5 meter UDL, consider that 5 meter length only during the point load conversion. For example, here I will draw the figure. This is the one more figure. The length of the beam is total 10 meter. and the UDL is applied to the center only, like this. And from the left side, it's 5 meter, and its length, its magnitude is 3 kilonewton per meter. Now, in this particular figure, you can see that the total length of the beam is 10 meter. No problem. The UDL is applied up to the center from the left side. How much amount of length is there for the UDL? 5 meter. So now I have to convert that particular UDL into the point load. So which is equal to W into L. So what is the magnitude of the UDL? 3. What is the length of UDL? 5. So you will get the load 15 kilonewton. Don't multiply by 10, because on the 10 meter length, UDL is not applied. UDL is applied only for the 5 meter length only. Therefore, we consider that length only while converting the UDL into the point load. So the load which is uniformly distributed, the load which is uniformly spread over the beam, that load is called as a uniformly distributed load. And how it is converted into the point load? That is equivalent point load is equal to W into L. W represents the magnitude of the UDL, length represents the length of that particular UDL. Okay. Then third is the triangular distributed load, which is also called as a uniformly varying load. In short, it is called as a UVL. First, we have discussed about the UDL, uniformly varying load. It is called as a UVL, or sometimes it is also called as a triangular distributed load. Okay. Now, what is the definition of UVL? The load is applied in the form of triangular manner. You can see it in this particular figure. Here, the figure is given. What is the circle I have made just now? The beam is supported at this particular support and the second support, but whatever the load is applied, it is applied in the triangular manner. Therefore, this is called as a triangular distributed load, or it is also called as a uniformly varying load. Simple definition is there. The intensity of load is increases or decreases at the constant rate. The intensity of load or intensity of loading is increases or decreases at a constant rate. It is known as a uniformly varying load. You can see in this particular figure, one triangle is there. Okay, this is the triangle. This W is present at the left side. That means the intensity is maximum at the left side. And from this particular top point, your load is continuously decreases towards the right point. And at this particular second point, the load W is equal to 0. That means here the intensity of load is decreases at the constant rate. Whatever the inclined line is present in this particular figure, that inclined line represents the intensity of load is decreases at constant rate. Therefore, that inclined line is provided. Now, in this particular figure, from this particular left side, right side, your load is continuously decreases at the constant rate. That particular load is called as a uniformly varying load. In second figure, if I will draw the one more figure, for example, here I will draw. Exactly opposite. Okay. At the right side, the W is maximum. And at this particular side, W is equal to 0. So what this particular second figure indicates, the intensity of load increases at the constant rate. That means at the left side, the load is 0. But when it is moving to the right side, it is continuously increases. That means from the left to the right direction, the intensity of load is increases at the constant rate. Yes, from the left to right direction, the intensity of load is increases at the constant rate. Therefore, your line is perfectly inclined. Means from left to right direction or from right to left direction, if your intensity of load is increases or decreases at constant rate, that particular load is called as a UVL. Or sometimes that particular UVL, it is also called as a triangular distributed load. Therefore, here the sign convention is also very important. The point load is indicated by the vertical line only. The UDL is represented, which is represented by this particular figure, whatever we have just discussed just now, and that UVL is represented in the form of triangular manner. But what is the definition? That inclined line means it indicates either intensity is increases or either intensity is decreases at constant rate. मग एका बाजूला तुमची मॅग्निट्यूड जास्त असणार आहे, त्याच्या दुसऱ्या बाजूला मॅग्निट्यूड काय असणार आहे, झिरो असणार आहे. किंवा एका बाजूला तुमची मॅग्निट्यूड झिरो असणार आहे, त्याच्या दुसऱ्या मॅग्निट्यूड काय असणार आहे, जास्त आहे. म्हणजेच काय होत आहे, एका बाजून दुसऱ्या बाजूला एकतर इंटेन्सिटी वाढलेली असणार आहे, म्हणजे तुमचा ट्रायंगल तयार झालेला आहे, किंवा टॉप पोझिशन पासून तुमची इंटेन्सिटी खाली काय झालेलं आहे, डिक्रीज झालेलं आहे. मग काय झालं, तिथं तुमचं inclined line provide केलेलं आहे. Means the intensity of loading is increases or decreases at the constant rate. The load is called as UVL. Okay, and how to convert that particular UVL into the point load? जसं UDL आपण point load मध्ये convert केलं, UDL is equal to W into L. Similarly, UVL also we have to convert into the point load, and you will get that particular value. Point load is equal to WL divided by 2. What that particular WL divided by 2 indicates? What that particular W into L divided by 2 indicates? Here. Now, here, whatever the beam I have drawn, that particular beam is subjected to the UVL load. Why it is subjected to the UVL? Because at the point A, the load value is 5 kilonewton meter. At this particular another support, point B, the W is equal to 0. Therefore, here the intensity of load is decreases at the constant rate from left to right direction. The intensity of load is decreases. Therefore, this particular load is called as a UVL. But it is not possible to take this 5 kilonewton meter as it is for the further calculation. जसं UDL मध्ये आपण 5 kilonewton meter, 10 kilonewton meter, 3 kilonewton meter, we are not taking that magnitude as it is for the further calculation. We are converting that particular UDL into the point load. That is, point load is equal to W into length. Similarly, this UVL also we have to convert into the point load, and that formula, point load is equal to W into L divided by 2. UDL चा फॉर्म्युला काय आहे? Only W into L. UVL चा फॉर्म्युला काय आहे? W into L divided by 2. So what is the value of UVL? 5. What is the length of this particular beam? 3 divided by 2. So 15 divided by 2 means 7.5 kilonewton. This 7.5 kilonewton represents the UVL converted into the point load. So please keep in mind, if we are converting the UDL into point load, formula is W into length. And if we are converting that particular UVL into point load, the formula is W into L divided by 2. So these are the two important conditions which we have to understood, because if we are not converting that UDL and UVL into the point load, and we are taking their magnitude as it is for the shear force calculation and for the bending moment calculation, your calculation will also wrong, your Sfd and Bmd will also wrong. Therefore, if the point load is given, take that point load as it is for the calculation. If UDL is given, convert that particular UDL by using the formula UDL converted into the point load, which is equal to W into length. UDL ची मॅग्निट्यूड W असणार आहे, किती लेंथ वर तुमचं UDL स्प्रेड झालेला असणार आहे तेवढीच लेंथ फक्त consider करा. Similarly, in case of UVL, we are having the formula W into length divided by 2. W represents the magnitude of the UVL. Length, किती लेंथ वर तुमचा UVL स्प्रेड झालेला आहे तेवढीच लेंथ आपल्याला फक्त काय करायचे, कन्सिडर करायचे, आणि त्याला काय करायचंय, 2 न डिवाइड करायचं. In UDL, this dividing factor is not there. This 2 is not present at the denominator. But in case of UVL, this dividing factor is to be represented. Therefore, point load means it is the load which is acts at a point on beam. That load is called as a point load, or it is also called as a concentrated load. UDL means the load which is uniformly distributed or spread over the beam. That load is called as a uniformly distributed load. UVL, the load or the intensity of loading or the load which is increases or decreases at constant rate. That particular load is called as a UPL. Also, it is called as a triangular distributed load. So these are the three important types of the loads which we have to discuss in this particular chapter, and based on this we have to solve the numericals. Then this is the trapezoidal load. The figure number 1 for the point load. This is UDL. This is UVL. The fourth number figure is the trapezoidal load. Here, its construction is similar to that of trapezoidal load. That means here, this particular figure indicates the combination of UDL and UVL. If the combination of UDL and UVL is there, that particular combination is called as a trapezoidal distributed load. How the construction will be like that? It is also similar to, for example, you can see here. If I will pick a word, this is the section number 1. म्हणजे काय झाला तुमचा UVL झाला आणि खालच्या बाजूचा जो काय
Sir, voice is breaking.
झाला तुमचा दुसरा झाला तुमचा
Sir, voice is breaking.
UDL. This is UVL. Okay. Now clear?
No, sir.
Okay. So now my voice is audible.
No proper, sir.
Am I audible now?
Yes, sir.
Yes, sir.
Okay. So we were discussing about the fourth load, which is called as a trapezoidal. Different types of load. Only it is the combination
Sir, again,
UVL
voice is breaking.
and the based on the
वॉइस नहीं क्लियर सर.
okay. Okay, am I audible now?
Yes, sir.
Okay. Okay, so we are discussing about the trapezoidal load. So the trapezoidal load is just combination of UDL and the UVL. Okay, but based on this particular type, we are not having any problems, but just it is a combination of UDL and UVL only. But what are the last point is there? Movement, or it is also called as a couple. The movement, or it is also called as a coupled. We know the basic definition of movement. Movement is equal to force into perpendicular distance. If I have to take the movement at any point, so what I am doing, I will take one force and the loading point, and at what point I have to take that particular movement, that distance represents the perpendicular distance. Therefore, the force into perpendicular distance, it is called as a couple. So it is always represented in the last figure. You can see here, one beam is there, and on that particular beam, it is represented in the form of a circular manner. Also in the second figure also, it is represented in the circular manner. Okay, but in shear force and the bending moment calculation, this point is very important. In shear force and bending moment calculation, the effect of couple or effect of moment will not be considered in the SF calculation, but the effect of couple and the effect of moment will be considered in the bending moment calculation, because shear force, it will be available only in kilonewton. The value of the shear force you will get in kilonewton or newton, but whatever the bending moment we are calculating, bending moment means force into perpendicular distance, then what is the unit? Kilonewton meter, or we can say Newton mm. And this particular couple is also having the same definition, force into perpendicular distance, means that couple is also having the unit kilonewton meter, or it is in Newton mm. Therefore, in the shear force and bending moment calculation, the effect of couple will not be considered in the shear force, but the effect of couple will be considered in bending moment diagram. So if the couple is given in the figure, so its magnitude directly given. For example, couple value is 50 kilonewton meter. Directly it is given kilonewton meter. That means already we have multiplied by that particular distance. So whatever the 50 we have calculated, that 50 you will get after the multiplication of load and the length also. Therefore, please keep in mind the effect of couple or the effect of moment will be considered in the shear force, will not be considered in the shear force calculation, but the effect of couple or the effect of moment will be considered in the bending moment calculation, because couple means kilonewton meter or Newton mm, and whatever the bending moment we are doing, that bending moment means your kilonewton meter or Newton mm. So please keep in mind this particular point is very important. Sometimes many students are considering the effect of couple in shear force also and effect of couple in bending moment also. But in case of a shear force, the effect of couple is totally negligible. It is totally neglected, because the shear force is given in kilonewton only, but the couple is given in kilonewton meter. Couple म्हणजेच काय, एक प्रकारचा movement आहे. Therefore, consider the effect of couple in the bending moment diagram or in bending moment calculation. Okay, so this is the one point. Now another point, we have discussed about the UDL and UVL. Just once I can see, this is the first figure for UDL. Same beam I will draw here, and the second beam is subjected to the UVL. The point A is present at the left, point B at the right. Similarly, second figure A, B for the UVL. This is for the UVL. So here, this UVL 10 kilonewton, and the width of the beam is 5 meter. Same magnitude will consider for the UVL Newton meter, and its length is also 5 meter. Now, if I have to convert that particular UDL into the point load, we are having the formula W into length. Okay, if this load is converted or UDL is converted into the point load, this UDL which is converted from the point load, it is always acts at the center point only. So what is the magnitude of the UDL? This 10 into 5 means 50 kilonewton. This UDL is always act at the center, means 2.5 meter here and the 2.5 meter here. Whatever the UDL we are converted into the point load, and that converted UDL, if it is acting on that particular beam, it is always at the center of that particular UDL. आता ह्या फिगर मध्ये बघा, टोटल 5 मीटर वर तुमचा UDL काय झालेला आहे, स्प्रेड झालेला आहे. तर तो सगळे UDL ची व्हॅल्यू आपल्याला पॉइंट लोड मध्ये काय करायचे, कन्वर्ट करायचे. फॉर्म्युला माहिती आहे W इंटू लेंथ. मग W म्हणजे UDL ची मॅग्निट्यूड किती दिले, 3 किलोन्यूटन मीटर. किती मीटर तुमचा UDL स्प्रेड झाला, 5 मीटरवर, म्हणजे लेंथ किती घेणार, 10 इंटू यू गेट द 50 किलोन्यूटन. तर
Sir, voice is not proper.
Okay, so on how much amount of length this particular UDL is spread, that is 5 meter length is there. Okay, if that UDL is converted into the point load, you will get the magnitude W into L, 50 kilonewton, but it will be act at the center. म्हणजे 5 मीटर जी काय टोटल लेंथ आहे, त्या 5 मीटरच्या बरोबर सेंटरला तुमचा हा UDL चा पॉइंट लोड काय होणार आहे, ऍक्ट होणार. म्हणजे 2.5 meter from the left side and 2.5 meter from the right side. So this is the basic requirement. If UDL is converted into the point load, that point load will be acts at the center of that particular UDL. कुठला सेंटर, जेवढ्या लेंथ वर तुमचा UDL स्प्रेड झालेला आहे त्या लेंथचा सेंटर. आता ह्या ऍप्लिकेशन मध्ये किती मीटरवर तुमचा UDL स्प्रेड झालेला आहे, फॉर एक्झाम्पल 5 मीटरवर. मग 5 मीटरचा सेंटर पॉइंट किती येणार आहे तुमचा, 2.5 meter फ्रॉम द लेफ्ट साइड अँड 2.5 meter फ्रॉम द राइट साइड. देयरफॉर इट विल बी एक्ट्स at the center. But in case of a UVL, what is the formula for the UVL? W into length divided by 2. So what is the value of W? 10. What is the length? 5 divided by 2. So 50 divided by 2 means you will get the magnitude 25 kilonewton. UDL मध्ये आपण पॉइंट लोड कन्वर्ट करून UDL चा पॉइंट लोड कन्वर्ट करून किती आला आपल्याला, 50 kilonewton. But in case of a UVL, if I am converting that particular UVL into the point load, you will get the magnitude as a 25 because we are having the formula W into L divided by 2. Now, if I have to represent that particular 25 kilonewton on the figure, this is the 25 kilonewton. So it will be not at the center of the 5 meter. म्हणजे बघा, ह्या वरच्या फिगर मध्ये 5 मीटरवर तुमचा UDL आहे. तो UDL कन्वर्ट केल्यानंतर तो 2.5 meter फ्रॉम द लेफ्ट साइड अँड 2.5 meter फ्रॉम द राइट साइड, म्हणजे बरोबर सेंटरला ऍक्ट झालेला आहे. बट इन केस ऑफ UVL, दिस 25 kilonewton लोड विल नॉट बी ऍक्ट्स ऍट द सेंटर. तर तो काय होणार आहे बघा, हा 25 kilonewtonचा पॉइंट आहे कुठला, लोडवर. तर लेफ्ट साइड पासून त्याचा डिस्टन्स असणार आहे L/3 अँड राइट साइड पासून त्याचं डिस्टन्स असणार आहे 2L डिवाइडेड बाय 3. जे UDL मध्ये लेफ्ट साइडला पण 2.5 मीटर अँड राइट साइडला पण 2.5 मीटर. बट इन केस ऑफ ए UVL इट विल नॉट बी ऍक्ट ऍट द सेंटर. तर जो काय त्या पॉइंटला ऍक्ट झालेला आहे त्या पॉइंटचं डिस्टन्स लेफ्ट साइड पासून L/3 असणार आहे आणि ह्या राइट साइड पासून 2L/3 असणार आहे. पण तो जर UVL आपण उलटा काढला, आता बघा इकडच्या ह्या फिगर मध्ये, इन दिस पर्टिक्युलर फिगर At point A, the magnitude is maximum. किती आहे 10 kilonewton meter. At point B, magnitude is 0. ज्या बाजूला मॅग्निट्यूड मॅक्सिमम आहे त्या बाजूपासून त्या पॉइंट लोड पर्यंत तुमची लेंथ काय असणार आहे L/3. आणि ज्या बाजूला पॉइंट तुमचा 0 आहे, युव्हीएल 0 आहे, त्या बाजूपासून त्या पॉइंट लोड पर्यंत हा काय असणार आहे 2L/3. हा जर मी ट्रायंगल उलटा काढला लाईक दिस, आता हे तर किती असणार आहे तुमचा 10 kilonewton मीटर. हा तुमचा पॉइंट ए आहे, हा तुमचा पॉइंट बी आहे. म्हणजे आता उलट झालं, बी पॉइंटला तुमची मॅग्निट्यूड जास्त आहे, ए पॉइंटला तुमची मॅग्निट्यूड कमी आहे. मी ह्याचा पॉइंट लोड मध्ये कन्वर्ट केला, किती आलाय मला 25 kilonewton. पण मला आता त्याची लेंथ दाखवायची, हा सेंटरला तर राईट जाणार आहे. मॅक्सिमम साईड कुठल्या बाजूला आहे पॉइंट बी, म्हणजे पॉइंट बी पासून हा किती आला L/3 आणि या 0 पासून हा किती झाला 2L/3. So this is indication is very important. The UDL is acts at the center only, but UVL it will not be acts at the center. From the maximum magnitude, its distance is L/3, and from 0 magnitude, its distance is 2L/3. L/3 means 5 meter divided by 3, and 2L/3 means 2 into 5 meter divided by 3. But in case of a UDL, from left side also L/2, and from right side also L/2. So please keep in mind, when the UDL is converted into the point load, that UDL will be acts at the center point of the UDL. जेवढ्या लेंथवर UDL स्प्रेड झालेला आहे तेवढ्याच लेंथचा सेंटर पॉइंट. आता ह्या फिगर मध्ये बीमच्या सगळ्या लेंथवर तो स्प्रेड झालेला आहे, त्यामुळे 2.5 मीटर 2.5 मीटर बरोबर सेंटरला. In case of a UVL, it will be not acts at the center. It will be acts as a L/3 from the maximum magnitude and 2L/3 from the 0 magnitude. त्यामुळे जरी तुम्हाला UVL अपोजिट डायरेक्शन मध्ये दिला असेल, लेफ्ट साइडला मॅक्सिमम आहे, राईट साइडला 0 आहे, किंवा राईट साइडला मॅक्सिमम आहे, लेफ्ट साइडला 0 आहे, जी काय त्याची मॅक्सिमम मॅग्निट्यूड आहे, त्या मॅग्निट्यूड पासून जिथं आपण पॉइंट लोड इंडिकेट केलेला आहे त्या पॉइंट पर्यंत त्याचं डिस्टन्स काय असणार आहे L/3. आणि राहिलेल्या 0 पॉइंट पासून त्याच्या पॉइंट लोड पर्यंत राहिलेली मॅग्निट्यूड काय असणार आहे 2L/3. So please keep this particular distances in your mind, or take this particular all the important things in your notebook. In UDL, L/2, L/2. In case of a UVL, L/3 and the 2L/3. So this is about the importance related to the UDL and the UVL. If you understand this particular two things in this particular chapter, you can solve any type of numerical based on the Sfd and Bmd. Many times the students are making the mistake while converting the UDL into the point load and their distances, and while converting the UVL into point load and their distances. Therefore, for the UDL, point load W into L, distance L/2, L/2. For UVL, W point load W into L divided by 2, and distance is L/3 from the maximum side and 2L/3 from the 0 side. Okay, so this is about the types of the loads in which we have discussed about the point load, UDL, how it is converted into the point load, then UVL, how it is converted into the point load, then trapezoidal means it is the combination of UDL and the UVL, and couple, which is also called as a movement. The effect of couple we are not considering in shear force calculation or in shear force diagram, but the effect of couple we have to consider in bending moment calculation. Also we have to show it in the bending moment diagram. So this is about the types of loads. Have understood the basic difference between the UDL and UVL? Yes, anybody have any problem? You have not understood how UDL is converted into the point load and how UVL is converted into the point load, and what about their distances? Yes, have understood all the things?
UVL करते काय?
Yes,
UVL सर UVL.
UVL. Okay. So I will repeat UVL once again. I will draw the figure in opposite direction, or I will draw both the figures. Okay, its magnitude is 10 kilonewton meter maximum side. This is point A, this is point B. Similarly, this is point A, this is point B. Here also 10 kilonewton meter. So here its length is 2 meter. I will take here its length is 2 meter. Okay, now this is the UVL. Okay, the force is given in the form of triangular section. Therefore, this load is called as a UVL. That means the intensity of load is increases or decreases. In the figure number 1, here figure number 1 and figure number 2. Here the intensity of load is increases from point A to B. A ला किती आहे 0, B ला किती आहे 10 kilonewton meter. त्यामुळे ह्या लोडला काय म्हणायचं UVL. In the second figure, the intensity of load is decreases from point A to B. A ला किती आहे 10, B ला किती आहे 0. म्हणजे फिगर नंबर 1 मध्ये intensity of load is increases at the constant rate, and here in the second figure the intensity of load is decreases. But as per our definition, maybe intensity is increases or decreases at the constant rate. That particular load is called as a UVL. Therefore, the first figure is also applicable for the UVL. Second figure is also applicable for the UVL. Now, I have to convert that particular UVL into the point load. Formula काय? W into length divided by 2. Similarly, for the second, W into length divided by 2. So, W 10 into 2 divided by 2. This 2, it will get cancelled. You will get the load 10 kilonewton. Similarly, for the second figure, again load 10, length 2 divided by 2. Again, you will get point load. Means, by using the magnitude of UVL, I have converted into the point load by using the formula W into L. Now, I have to indicate this particular 10 kilonewton force on the figure. जो काही UVL आपण पॉइंट लोड मध्ये कन्वर्ट केलेला आहे तो UVL मला ह्या फिगर मध्ये दाखवायचा. तर मी काय करणार बघा, एक व्हर्टिकल लाईन काढणार. फिगर नंबर 1 मध्ये पण काढली. किती लोड आहे 10 kilonewton. तसंच दुसऱ्या फिगर मध्ये पण काढणार. हाऊ मच 10 kilonewton. हे काय डिस्टन्स मोजून टाकायचं नाही. L/3 किंवा 2L/3 हे डिस्टन्स काय लेफ्ट साइड किंवा राईट पासून आपल्याला मोजून टाकायचं नाही. अंदाजे फक्त आपल्याला काय करायचंय इंडिकेट करायचंय. सो 10 kilonewton in the both figures I have indicated. But UVL is not applied at the center. 2 मीटर लेंथ आहे, 2 मीटर लेंथ आहे. 1 मीटर लेफ्ट साइड पासून राईट, 1 मीटर राईट साइड पासून. इट इज नॉट अ UVL. इथं जर UVL असला असता तर बरोबर तो सेंटरला 1 मीटरला अप्लाय झाला असता. बट हियर इट इज UVL and I have told whatever the L/3 distance is there, that L/3 distance we have to represent from the maximum side. आता फिगर नंबर 1 मध्ये मॅक्सिमम मॅग्निट्यूड कुठल्या बाजूला आहे? A पॉइंटला आहे का B पॉइंटला आहे? प्लीज टेल मी. In figure number 1, maximum magnitude is present at A or B?
And B.
A.
A or B? Point B. मग पॉइंट B पासून हा जो काही 10 kilonewtonचा फोर्स आपण इंडिकेट केलेला आहे त्याला आपण C म्हणूया फॉर एक्झाम्पल. हा C पॉइंट. तसंच सेकंड फिगर मध्ये पण C पॉइंट. तर ह्या C मधलं आणि ह्या B मधलं डिस्टन्स काय झालं तुमचं L/3. मग L/3 जर हे असेल तर AC डिस्टन्स किती होणार तुमचं 2L/3. Getting? Now in the second figure, maximum magnitude is present at A or B?
A.
Again. मग मॅक्सिमम मॅग्निट्यूड पासून ह्या पॉइंट लोड पर्यंत तुमचं डिस्टन्स काय असणार आहे? हे झालं L/3 आणि हे BC डिस्टन्स काय झालं 2L/3. L/3 म्हणजेच काय 2/3. लेंथ किती आहे 2 मीटर/3. 2L/3 मीन्स 2 into 2 divided by 3. सो प्लीज कीप इन माइंड. तुम्ही फक्त L/3 जर डिस्टन्स लक्षात ठेवलं ते कुठल्या बाजूने इंडिकेट करायचं आपल्याला तर मॅक्सिमम मॅग्निट्यूड. ह्या मॅक्सिमम मॅग्निट्यूडच्या पॉइंट पासून जिथं तुम्ही पॉइंट लोड इंडिकेट केला हा C पॉइंट, त्या C पॉइंटचं डिस्टन्स म्हणजेच L/3. त्यामुळे मी दोन्ही दाखवताना तुम्हाला काय दाखवलंय, एक UVL असा दाखवलाय आणि दुसरा यू वेल लाईक दिस. बोथ आर इन अपोजिट डायरेक्शन. एका बाजूला इंटेन्सिटी ऑफ लोड इन्क्रीज व्हायला लागलेला आहे, दुसऱ्या फिगर मध्ये इंटेन्सिटी ऑफ लोड काय व्हायला लागलाय, डिक्रीज व्हायला लागलाय. त्यामुळं L/3 डिस्टन्स हे कुठं असणार आहे, तुमच्या आलेल्या पॉईंट लोड पासून मॅक्सिमम मॅग्निट्यूड जिथं आहे तिथपर्यंत डिस्टन्स म्हणजे L/3. मग हे L/3 असेल तर राहिलेलं डिस्टन्स 2L/3. तसंच सेकंड फिगर मध्ये मॅक्सिमम मॅग्निट्यूड हे पॉईंट ए कडे आहे, त्यामुळं तिथून सी पॉईंट पर्यंत डिस्टन्स म्हणजे L/3 आणि हे जर L/3 असेल एसी डिस्टन्स तर राहिलेलं काय असणार आहे तुमचं 2L/3. गेटिंग नाव स्वप्नील?
Yes, sir. Yes.
Yes. What about others? Everyone has understood this particular concept?
Yes, sir. Understood.
Okay. So only this point is very important. If you are able to convert this particular all the UDL, UL into the point load, and if we are representing their distances, maybe L/2, L/3, 2L/3, you can solve any type of numerical based on this. Okay, these are the about the types of beams. Now, types of supports. It is very simple. Types of supports. Now, the first support is called as a roller support. You can see here. The first support is called as a roller support. How it is to be indicated? How it is to be indicated roller support? You can see here. It is represented. One triangle is there, and below this particular triangle, two circles are there. And below that, the fixed condition is there. So this is the symbol for the roller support. Okay. If the roller support is given, or any beam, if it is supported by the roller support, then it is having only one reaction. You can see here. Reaction force in which direction? Vertical only. That is vertical load. If the roller support is given, it is having only one reaction, which is indicated by the capital R or the RY. If any beam is supported by the roller supports, so that roller support can be replaced by the vertical reaction only. Please keep in mind, if the roller support is given in any type of beam, that roller support is having only one reaction, which is perpendicular to the contact surface. Contact surface म्हणजे कुठला? हा खालच्या बाजूच्या काय हॅचिंग लाईन आहेत फिक्स्ड साइडच्या, त्या फिक्स्ड साइडला ही तुमची रिएक्शन कशी आहे? परपेंडिक्युलर आहे. Therefore, what is the definition of roller support? It has only one reaction. It has only one reaction which is perpendicular to the contact surface. That particular support is called as a roller support. That means it is having only one reaction. That means in vertical direction, which can be indicated by capital R, or it is indicated by the RY. R means reaction, Y means vertical direction. Then second support is the pinned support. What is the symbol for the pinned support? You can see here. Only triangle is there. Okay, only triangle is there, and below this particular triangle, these hatching lines are there. So understand the difference between the roller support and the pinned support. In roller support, one triangle, below that two circles, and below that it is fixed. But in case of a pinned support, only triangle is there, and below that fixed. Then what is the definition of fixed support? What is the definition of pinned support? This pin support, it is also called as hinged support. Please keep in mind. Pinned support, it is also called as a hinged support, and it has two reactions. One is horizontal, one is vertical. You can see vertical reaction can be represented like this, and the horizontal reaction can be represented. Horizontal reaction is represented by the Rx, and vertical reaction can be represented by the RY. So pinned support or the hinged support means it is having the two reactions. That means it is having the restriction to move in X direction and the Y direction. In case of a roller support, it is having restriction to move in the Y direction only, because only one support is there in the Y direction. In second, pinned support, it is also called as a hinged support, means it is having the two reactions. one is in the horizontal direction, another is in vertical direction, means it is having restriction to move in x direction and to move in the y direction. त्यामुळे रोलर सपोर्ट मध्ये आणि हिंज्ड सपोर्ट मध्ये एकच डिफरन्स आहे. रोलर सपोर्ट मध्ये एकच रिएक्शन आहे, ती फक्त व्हर्टिकल डायरेक्शन मध्ये आहे. हिंज्ड सपोर्ट मध्ये किंवा पिनड सपोर्ट मध्ये दोन रिएक्शन आहेत, एक म्हणजे एक्स डायरेक्शन मध्ये आणि दुसरी म्हणजे वाय डायरेक्शन मध्ये. देन थर्ड, फिक्स्ड सपोर्ट. इट इज लाईक ए कॅन्टिलिव्हर. यू कॅन सी फिक्स्ड सपोर्ट मीन्स the structure is like cantilever, means one end is fixed, another end is free. You can see in the figure मध्ये काय दिसतंय, हे structure it is look like a cantilever beam. Left side is fixed and the right side is totally free. Means what that particular support indicates? It indicates it has three reactions. It has three reactions. Let us see. One is horizontal, Rx. One is vertical, Ry, and this fixed support is also subjected to one movement. This fixed support is also subjected to one movement. That is, it is represented in the form of half circular manner. म्हणजे Rx horizontal reaction पण आहे, Ry vertical reaction is also there. Also, it is subjected to one movement. Means it is having restriction to move in the x direction, to move in the y direction, as well as to restrict about their own axis also. बघा, हे मूवमेंट कसा इंडिकेट केलाय, तर इट इज लाईक ए कपल. त्या पॉइंटला एक कपल पण असतो. That particular support is called as a fixed support. So the fixed support is the support in which it is having the three reactions. Out of that, one is the horizontal reaction, which is indicated by Rx. Another is the vertical reaction, which is indicated by the Ry. Also, it is subjected to one movement, or it is also subjected to one couple, which is indicated by the capital M. म्हणजे Rx पण आहे, Ry पण आहे आणि capital पण M पण आहे. म्हणजेच it is subjected to the three reactions, that is horizontal, vertical, and the movement. Again, understand the basic difference. In roller support, only one support is there, which is applied in the y direction. In the pinned support or the hinged support, it is having the two directions, that is in Rx and Ry. In the third figure, in the fixed support, which is look like say a cantilever beam, it is having the three reactions. One is Rx, another is Ry, and third one is a movement. And the last support is the simply support. You can see here the simply support means from the bottom side the beam is supported and another it is free. It is having only vertical reaction, which is represented by the Ry. Simply supported means it is having only one reaction, which is represented by the Ry. So these are the different types of the supports which will be given in the type of the beam, and by using that particular supports we have to find out their values. But please keep in mind, in case of a SF calculation and the BM calculation, we are considering only vertical reactions and the vertical forces only. Please keep in mind, in case of a SFD and the BMD calculation, we are considering only vertical forces and the vertical reactions only. So in the second, pinned support or hinged support, Rx is also there, but we are not considering the effect of Rx in the shear force calculation and the bending moment calculation. Similarly, in case of a fixed support, again Rx is there. Rx means horizontal reaction, but in case of a shear force calculation and in case of a bending moment calculation, the horizontal reactions or horizontal forces will not be considered in the shear force calculation and the bending moment calculation. Only we are considering this Ry for the roller support, Ry for the pinned support, Ry for the fixed support along with this movement, and in case of a simply support also again Ry is there. That means we are considering only vertical reactions and the vertical forces. Otherwise, the effect of horizontal forces, that is Rx, it will be not considered in the shear force calculation and the bending moment calculation. Okay, so these are the different types of the supports which will be given in the statement or in the figure. We have to convert that particular support in the form of reaction. काही ठिकाणी तुम्हाला फिगर मध्ये डायरेक्ट रिएक्शन पण दिलेले असते. फॉर एक्झाम्पल here I will draw one figure. If in some of the figures directly such types of the reactions will be given. This is point A and this is point B. So here directly supports are given, but in some of the figures the supports will be represented in the form of, for example, at the left side, for example, roller support is there. Okay, and at the right side pinned support or the hinged support is there. So that roller support can be replaced in the form of vertical reactions only. Means here I will draw one vertical line. At the right side, this hinged support is also replaced by the reactions. So it is having Ry also and it is having Rx also. But the effect of Rx will not be considered in the calculation. Only effect of Ry at the right side and effect of Ry at the left side, it will be considered during the calculation. त्यामुळे जरी फिगर मध्ये तुम्हाला हा Rx दिसत असेल कारण तो पिनड सपोर्ट आहे, तसंच ह्या फिक्स्ड सपोर्ट मध्ये जरी फिगर मध्ये तुम्हाला तो रिएक्शन Rx दिसत असेल, पण तो Rx इफेक्ट किंवा ती हॉरिझॉन्टल रिएक्शन किंवा तो हॉरिझॉन्टल फोर्स आपण शियर फोर्स अँड बेंडिंग मोमेंट कॅल्क्युलेशन मध्ये कन्सिडर करत नाही. त्यामुळे SF आणि BM कॅल्क्युलेशन करताना आपण फक्त व्हर्टिकल रिएक्शन आणि व्हर्टिकल फोर्सेस फक्त काय करणार आहे, कन्सिडर करणार. ओके, सो दिस इज अबाउट द डिफरंट टाइप्स ऑफ द सपोर्ट्स. Now these are the relation. Now just now we have discussed about the, we have initially if I have to draw the shear force and bending moment diagram, initially if I have to draw the shear force and bending moment diagram, so what is my first requirement? First of all I have to go for the shear force calculation. If I have to draw the bending moment diagram, again I have to go for the bending moment calculation. Means without calculation it is not possible to draw the shear force diagram and the bending moment diagram. So first of all I have to calculate the shear force at the different points. For example, shear force point, shear force at A, B, C, D, like that. Shear force, sorry, bending moment at also bending moment at point A, B, C, D, like that. If I will do the calculation, then and then only by using that particular calculation I can draw the shear force diagram, bending moment diagram. But if I have to draw the shear force and the bending moment diagram and the different types of the loads are given, if the point load is given, how to draw the shear force and bending moment diagram? If UDL is given, how to draw the shear force and bending moment diagram? If UVL is given, how to draw the shear force and the bending moment diagram? Calculation part I am having, but in order to show that particular diagram, whether I have to represent by the vertical line or whether I have to represent by the horizontal line or whether I have to use the inclined line or whether I have to use the parabolic curve or whether I have to use the cubic curve, which types of the curve, which types of the line will be applicable for the which types of the loads, that we have to understood first, and then by using that particular calculation I can convert that calculation in the form of diagram. Therefore this relation is very, very important. Therefore here you can see in the first column the type of load is there. So the first one is a point load. The figure of the point load is given here. The second column will be applicable for the UDL. The figure is also given for the UDL. The third column will be applicable for the UVL. The figure of the UVL is also given. Now, here the second row, it indicates the shear force, and third row, it will indicate the movement, or it is also called as a bending moment. Now, if the type of load is given as a point load, the type of load is given as a point load, and if I have to draw that particular point load in the form of shear force, so it can be represented by the vertical line or the horizontal line. So whatever the shear force calculation I have done, Whatever the shear force calculation I have done, in that particular shear force calculation, if point load is there, that shear force calculation of the point load can be represented either by the vertical line or the horizontal line. Similarly, in the same load, if UDL is given, that UDL can be represented in the shear force diagram in the form of a inclined line. You can see the figure. Go for the matching. This is the shear force. This is the UDL. So if I will represent the UDL in the shear force diagram, it can be represented by the inclined line. Similarly, if I will represent this UVL in the shear force diagram, it can be represented by using the parabolic curve. So in case of a shear force, the point load can be represented by the vertical line or the horizontal line. Then this UDL can be represented by the inclined line, and this UVL can be represented by the parabolic curve. Similarly, in case of a bending moment diagram, the point load can be represented by the inclined or the linear line. Similarly, UDL, in case of a bending moment diagram, this UDL can be represented by the parabolic curve, and in case of a bending moment diagram, UVL can be represented by the cubic curve. This understanding is very important. If you understood this particular chart properly, then and then only it is possible to draw the Sfd and the Bmd. If you are unable to understand this particular chart, it is very difficult to draw the Sfd and Bmd, because if the point load is given and we are not aware how the point load will be represented in the form of Sfd and how the point load will be represented in the form of Bmd. So for that purpose, you have to understood this particular things. This particular chart, it should be at your tip of tongue. दोन पार्टच तुमचा हा चार्ट असला पाहिजे. त्यामुळे if point load is given in the shear force diagram, the point load will be represented by the vertical or the inclined line. That point load can be represented in the bending moment diagram by the inclined line. Then second load, UDL. In shear force diagram, UDL can be represented by the linear or the inclined line. But in the BMD, it can be represented by the parabolic curve. Third load, UVL. In shear force, it can be represented by the parabolic curve. And in bending moment diagram, it can be represented by the cubic curve. So understanding of this particular table is very important. If you understood this particular table, you are able to convert your shear force calculation in the Sfd, and you are able to convert your bending moment calculation in the form of Bmd. How to draw that particular figure, that we will see when we will start with the first numerical. But before that, you just understood that how the point load will be represented in Sfd and Bmd, how the UDL will be represented in the Sfd and Bmd, and how UVL will be represented in the Sfd and the Bmd. So take this particular chart in your notebook also, draw this particular chart also in your notebook, so you can understood very easily, and while solving the numericals also, this particular chart will be helpful. Automatically these figures will be generated, don't worry about that. Whatever the calculation we are doing while solving the numericals, based on that particular calculation, automatically such types of the figures will be generated. But whether these 2 points are joined by the inclined line, other way that 2 points are joined by the parabolic curve, or whether that 2 points are joined by the vertical line or horizontal line, or whether we have to use the cubic curve, that understanding is very important. Therefore, initially we have to understood this particular table properly, and then we will implement this particular table while drawing the Sfd and the Bmd. Okay, so this is the common relation, the relation between the loading, shear force and the bending moment. That means the relation between the shear force, bending moment on the all the types of loads. Okay. Okay. So now we take this particular 2 theoretical points and then we will stop. Now, while starting this particular chapter, I have discussed about this particular point of contra shear. This is a very important point which will be located in the Sfd and the bending moment diagram. It is having one standard definition. We can see it is the point at which the shear force changes its sign from positive to negative and vice versa. It is the point at which your shear force is changes from positive to negative or from negative to positive. That particular point is called as a point of contra shear, and at this particular point the shear force is zero and bending moment is maximum. जिथं shear force 0 असतो त्या ठिकाणी तुमचा बेंडिंग मोमेंट काय असतो, मॅक्सिमम असतो. असा जर पॉइंट तुम्हाला एसएफडी आणि बीएमडी मध्ये मिळालेला असेल तर त्या पॉइंटला आपण काय म्हणतो, पॉइंट ऑफ कॉन्ट्रा शियर. प्लीज कीप इन माइंड द पॉइंट ऑफ कॉन्ट्रा शियर, it is the point at which shear force is 0 and at the same point the bending moment is maximum. That particular point is called as a point of contra shear, or one more definition is there as per the first. It is the point at which the shear force changes its sign from positive to negative and from negative to positive. That particular point is called as a point of contra shear. For example, here I will draw one figure. I will draw one SFD. Yeah? This is the, let us assume that this is the shear force diagram. This is the SFD, and below this the bending moment diagram will be there. Okay. This is point A, B, C, D, and E. Similarly, point A, B, C, D, and E. So C point, we have to focus on the C point. This point C, I can call it as a point of contra shear. Point of contra shear. Why? Because here the definition will be satisfied. It is the point at which your shear force changes sign from positive to negative. You can see here, this is the positive diagram at the top side. This is the horizontal reference line. This is the reference line. Above this particular line, this will be the positive region. Below this particular line, this will be your negative region. So it is the point C is called as a point of contra shear. Why? Because it is the point at which shear force changes from positive to negative. बघा ह्या पॉइंट सी ला तुमची shear force diagram ही पॉझिटिव्ह कडून कुठे गेली, निगेटिव्ह ला गेली. Therefore this point is called as a point of contra shear. This is the first definition, whatever it is given. It is the point at which the shear force changes its sign from positive to negative. So here in this particular figure, shear force changes from positive to negative. Therefore, this particular point is called as a point of contra shear. In some of the figure, your shear force will be changes from negative to positive. Therefore, this vice versa, this word is also mentioned. Therefore, please keep in mind the point of contra shear. It is the point at which the shear force changes from positive to negative or from negative to positive. Therefore, that particular point is called as a point of contra shear, and this particular definition will be satisfied in this particular figure. That is, this point C indicates the point of contra shear because at this particular point C, the shear force diagram is changes from positive to negative. This is the first definition. Then second, it is the point at which shear force is 0. This is the 0 line. This is the 0 line. At this particular point C, shear force is 0, but at the same point the bending moment is maximum. बघा इन बेंडिंग मोमेंट डायग्राम मध्ये तुम्हाला दिसतंय पॉइंट सी ला काय तुमचा शेअर फोर्स 0 आहे, पण तोच पॉइंट जर आपण खाली बेंडिंग मोमेंट डायग्राम मध्ये जर बघितला पॉइंट सी, तर त्या सी पॉइंटला तुमचा बेंडिंग मोमेंट काय असतो, मॅक्सिमम असतो. त्यामुळं परत ह्या पॉइंटला आपण पॉइंट सी ला आपण काय म्हणतोय, पॉइंट ऑफ कॉन्ट्रा शियर. So please understand the two definitions. It is the point at which the shear force changes its sign from positive to negative or from negative to positive. That point is called as a point of contra shear. ती definition आपली ह्या पहिल्या फिगर मध्ये एसएफडी मध्ये आपली सॅटिस्फाय झाली, म्हणजे पॉझिटिव्ह कडून तुमचा निगेटिव्ह कडे शिअर फोर्स काय झालेला आहे, चेंज झालेला आहे. सेकंड डेफिनेशन, इट इज द पॉइंट ऍट विच शिअर फोर्स इज झिरो. इन एसएफडी at point C shear force is totally zero, but in bending moment diagram at point C the bending moment is maximum. Therefore once again this point C is also called as a point of contra shear. This is the point of contra shear. जिथं तुमचा शियर फोर्स पॉझिटिव्ह टू निगेटिव्ह और निगेटिव्ह टू पॉझिटिव्ह चेंज होते, किंवा त्या पॉइंटला शियर फोर्स झिरो असतो आणि बेंडिंग मोमेंट मॅक्सिमम असतो, तर त्या पॉइंटला आपण काय म्हणतो, पॉइंट ऑफ कॉन्ट्रा शियर. अँड एक्झॅक्टली अपोजिट पॉइंट ऑफ कॉन्ट्रा फ्लेक्चर. एक्झॅक्टली अपोजिट, इट इज द पॉइंट ऍट विच बेंडिंग मोमेंट चेंजेस इट्स साइन फ्रॉम पॉझिटिव्ह टू निगेटिव्ह. पॉइंट ऑफ कॉन्ट्रा शियर मध्ये शियर फोर्स चेंजिंग द साइन फ्रॉम पॉझिटिव्ह टू निगेटिव्ह and from negative to positive, that point is called as a point of contra shear. But in case of a point of contraflexure, bending moment changes its sign from positive to negative. That particular point is called as a point of contraflexure. And second definition is that it is the point at which bending moment is zero. Now I will draw figure. This is the zero line, this is the positive, this is the negative. So this is the one bending moment diagram. Let us assume that this is the one BMD. Okay, this is point A, this is the center point B, and this is point C. As per the definition, point of contraflexure, it is the point at which bending moment changes its sign from positive to negative. You can see at the top of the figure, this is the positive bending moment. This is the bottom negative bending moment. Means bending at this particular point B, your bending moment changes the sign from positive to negative. Therefore, this point B is called as a point of contraflexure. This is the first definition, की ज्या पॉइंटला तुमची बेंडिंग मोमेंट हे एकतर पॉझिटिव्ह कडून निगेटिव्ह कडे गेले किंवा निगेटिव्ह कडून पॉझिटिव्ह कडे आलेले आहे, त्यामुळे ह्या पॉइंट बी ला आपण काय म्हणतो, पॉइंट ऑफ कॉन्ट्राफ्लेक्चर. दुसरी डेफिनेशन, इट इज द पॉइंट ऍट विच बेंडिंग मोमेंट झिरो. बघा ह्या पॉइंट बी ला, पॉइंट ए ला हा तुमचा फिक्स्ड एंडचा सपोर्ट आहे, त्यामुळे ह्या पॉइंट ए ला तर सपोर्टला ऑलवेज बेंडिंग मोमेंट काय असतो, झिरो असतो. तसाच हा पॉइंट सी म्हणजे तुमच्या त्या बीमचा सपोर्ट आहे, ह्या सपोर्टला पण तुमचा बेंडिंग मोमेंट काय असतो, झिरो असतो. पण ह्या पॉइंट बी ला जिथे तुमचा साइन चेंज झालेला आहे, पॉझिटिव्ह टू निगेटिव्ह और फ्रॉम निगेटिव्ह टू पॉझिटिव्ह, अँड ऍट दिस पर्टिक्युलर पॉइंट द बेंडिंग मोमेंट इज इक्वल टू झिरो. देअरफॉर वन्स अगेन दिस पर्टिक्युलर पॉइंट बी इज कॉल्ड एज ए पॉइंट ऑफ contraflexure. So both the definitions are exactly opposite. Point of contra shear means shear force changes the sign from positive to negative and from negative to positive. That point is called as a point of contra shear. Second definition for the point of contra shear, it is the point at which shear force is zero in shear force diagram, but in bending moment diagram, bending moment is maximum. त्यामुळे जिथं शियर फोर्स झिरो असतो त्या पॉइंटला जर तुमचा बेंडिंग मोमेंट हा मॅक्सिमम येत असेल इन बेंडिंग मोमेंट डायग्राम मध्ये, तर त्या पॉइंटला आपण काय म्हणतो, पॉइंट ऑफ कॉन्ट्रा शियर. अँड द सेकंड डेफिनेशन एक्झॅक्टली अपोजिट टू द पॉइंट ऑफ कॉन्ट्रा शियर, इट इज द पॉइंट ऍट विच बेंडिंग मोमेंट चेंजेस इट्स साइन फ्रॉम पॉझिटिव्ह टू निगेटिव्ह अँड फ्रॉम निगेटिव्ह टू पॉझिटिव्ह. That point is called as a point of contraflexion. Therefore, here in this particular BMD, at this particular point B, the sign it changes from positive to negative or from negative to positive. Therefore, this particular point B is called as a point of contraflexure. First definition is satisfied. Second definition, what it is telling, it is the point at which bending moment is zero. At this particular same point B, your bending moment is also equal to zero. Therefore, this point is called as a point of contraflexure. And in many of the numericals, the question will be asked like that: draw the SFD and BMD for the above figure and indicate important points if any. And indicate important points if any. If any means if in this particular SFD and BMD, if point of contra shear is present, point of contraflexure is present, you have to indicate that particular point by arrow. We have to indicate that particular point by arrow. This particular point is the point of contra shear. This particular point is point of the contraflexure. Or sometimes in the statement, draw the SFD and BMD for the above loading diagram and show the point of contraflexure. त्यांनी स्टेटमेंट मध्ये विचारले शो द पॉइंट ऑफ कॉन्ट्राफ्लेक्चर, म्हणजे तुम्हाला बेंडिंग मोमेंट डायग्राम ड्रॉ केल्यानंतर 101% त्या डायग्राम मध्ये तुम्हाला पॉइंट ऑफ कॉन्ट्राफ्लेक्चर प्रेझेंट असणार आहे. Or sometimes show the point of contra shear, means in shear force diagram you will get the point of contra shear. If you will get that particular point, for example here I have indicated this point C, make the arrow like this and indicate point of contra shear like that. If you will indicate that particular point, separate 1 or 2 mark will be given to indicate the point of contra shear and the point of contraflexure. Some of the numericals, it will be asked in many of numericals only you have to draw the SFD and BMD. In some of the numericals, if they have given the statement, show important points, indicate important points, show point of contraflexure, show point of contra shear. If it will be given, you have to go for that SFD and BMD in the proper manner and identify where shear force is 0, where bending moment 0, where shear force maximum, where bending moment maximum. मग जिथं shear force 0 असतो पण बेंडिंग मोमेंट डायग्राम मध्ये जिथं बेंडिंग मोमेंट मॅक्सिमम असतो तर तो पॉईंट कुठला झाला तर तुमचा पॉईंट ऑफ कॉन्ट्रा शियर झाला. आणि जिथं बेंडिंग मोमेंट हा पूर्णपणे 0 असतो त्या पॉईंटला आपण काय म्हणतो पॉईंट ऑफ कॉन्ट्राफ्लेक्चर. ओके, सो दिस इज अबाउट द important definitions related to the point of contra shear and the point of contraflexure. Have you understood this particular part? Yes. Okay, so with this today we will stop here. The remaining part we will see in the next lecture.